welcome back to another episode of the Open Source Cafe. I'm really excited for this one. Today we have Guy joining us from BLST, and today we're going to talk a lot about APIs, right? So we're going to talk about API design, some of the best practices, things to keep in mind, and how to understand your APIs quickly by Swagger. So lots of discussions are about to happen, so make sure you check out the links in the description below. But before we get started, Guy, would you like to tell our viewers a little bit more about yourself?
Yeah. Well, my name is Guy. I'm the CTO of BLST Security. We are a business logic security testing company. We're based in Israel, me as well. I have some military background, some freelancing background. So we started a company with 4 people, and Chaim, our CEO, he met Kunal through YouTube, like some fun there. And we know Kunal for a few months now, so I said, let's have a podcast. So yeah, we're
Yeah, and
here.
apparently, like I know now so many people from Israel, so many tech startups, and the people that I've
Startup
talked to,
Nation.
and yeah, I met at KubeCon, like yes, Commodore and Armo, and like BLST, and so many people, like Tree. So it's nice, Actually,
Yeah,
planning to visit in December. There's the DevOps Days thing you have in December in Tel Aviv.
yeah,
Uh,
we're planning to be there. So yeah, come
yeah,
on, have fun. Come to our office as well.
yeah,
It'll be
yeah. I'll
it'll be
stop by.
great.
Yeah, looking forward to it. Cool.
Uh,
Yeah. So let's talk a little bit more about it. Like, before we talk about, the best practices and stuff, can you tell us a little bit more about API design and what basically is OS, like Open API specifications?
okay. Well, API design is the process that usually happens before you start developing the API. Some companies write open API specs before they develop the API to auto-generate API gateways or API routers if you're using like servers, written servers, to generate them without using code. It's a declarative format for your API to explain what kinds of payload should go into it, what kind of payload should not go into it, what it would return, what the authorization level should an endpoint accept, what scopes. I mean, it describes a lot of stuff on your API, and sometimes it's typed by hand, sometimes it's auto-generated from existing gateways to test them. And so yeah, it's usually in the design phase of the API.
See, yeah, and since we are talking about Open API, how is it different than something like GraphQL, for example?
Well, the OpenAPI spec usually refers to usually makes use of is usually best made use of in REST APIs, not in GraphQL APIs, because GraphQL APIs are kinds of monoliths. There is a single endpoint that you throw different payloads at it and it responds differently, rather than a REST API where there are different paths and the descriptive part of the API are the descriptive parts of the API are the paths, not the payloads themselves, so not only the payloads themselves.
Hmm.
GraphQL itself has its own schema that is worthwhile to test, and I won't go into that.
Cool. And since we're talking about it, can you maybe tell us a little bit more about what might be some of the main benefits when you're working with Open API specifications?
Well, the version 2, the Swagger file, is used in many companies, in many dinosaur companies to this date, but it's considered less documented and stuff like that. So I'll talk about OpenAPI itself. It's used in a variety of companies to generate your API gateways. It's a way to write your API gateway without actually configuring it. You write it declaratively. You write, well, I want to receive a payload with integers with a minimum of 0 and a maximum of 10, and it will auto-generate your API gateway with this validation right there. It's a pretty useful tool for user stories. I mean, you're a product manager, you create user stories, you like say this feature should be used like this, and then it needs to have an API to accommodate it. The direct relationship between business and operational API is in the API design phase. And OpenAPI gives a great solution for it if it's done correctly.
And you mentioned about Swagger. For folks who may be new to the term, can you maybe explain what is Swagger and how is it different than OpenAPI specification?
Well, OpenAPI specification is the version 3 of OpenAPI specifications. Swagger is the version 2. It's way less documented, more decentralized. Like some companies are using Swaggers without some of the standards that the organization set. I mean, it's kind of a mess compared to OpenAPI, which is very well documented. Some organizations took some organizations sponsor it, some major organizations sponsor it. I mean, it's very focused, regularized, and like the leading thing in API documentation today.
Yeah, and since we're talking about APIs, can you maybe touch upon a little bit more on the security part of OpenAPI, right? How does the authentication thing works with it, and what are some of, like, let's say, flaws that you may have encountered when companies work with APIs, and why that's like, so any stories you would want to highlight or case
I'll
studies or something. Yeah.
I'll give a story about us. Well, we use an open API spec. We started by using the regular API gateway configuration and stuff, and we quickly shifted away to open API specs because it was so much more declarative. And we actually had a near fatal error that might have reached production unless we used our own product on ourselves. Um, um, that one of our developers forgot to include an authentication function, an authenticator function. We run on AWS, so in API Gateway you have authenticators. On AWS you have authenticators that will run the authentication process, usually custom made. So one of our developers forgot to include an authenticator in the API gateway, and during the process of testing the OpenAPI spec, we actually discovered it and quickly fixed that mistake. It took 2 lines of code to fix that mistake, and it would have been devastating if this API would have reached production. And we wouldn't have known where the error is that quickly. I mean, it was an error in the design phase, not in the production phase. Like we had to go back all the time. We had to go back like way back to the design. It would have been a mess. So I'm thankful for the fact that we discovered it. Generally, those are the types of security misconfigurations you can encounter. You can encounter some other stuff like when you don't define minimum and maximum values to a variable that you accept, and the ingestion functions, like the functions that set boundaries to any parameter that validates that a parameter received, that an input received from a user is actually a suitable input for your system. They do not run those checks, so this might cause some business logic issues later that you couldn't trace back. Like if this type of thing happens in production, like how sure are you that you can trace it back to a missing if? It's speaking from experience, it's hard, very hard, and it takes days, if not weeks.
So since you mentioned about testing, and you gave this example, so when do you think is the right time? Like when should you test it?
Well, the OpenAPI spec, you should test it when you generate it. After you like run some sanity tests, when you write it, generate it, never mind. After you run some sanity tests on your OpenAPI spec, some sanity tests, security tests, check it out, you generate your gateways, and then you should retest it. You generate your API gateways, your developers write the code that runs behind the gateways, and then you should retest it. You should use it to test the implementation of the API. You should run some active scans to check that every single one of your conditions actually was executed by the developers in implementation. Because they usually go for something that works rather than understanding every little use case. So yeah, you should test it in design phase and integration and dev phases as well.
Yeah, there comes the point where you mentioned about figuring it out before it reaches production, right? So that's where the design stage comes in. But when we're talking about this, so that's all good and nice when we're talking about the implementation part. But you mentioned the business logic thing as well, the business logic misconfigurations that may not be so evident at first. So is testing really like enough for that, and how do you work with when it comes to poor business logics in your API?
Well, the thing is, sometimes in the shift left type environment, in like the design phases and dev phases, integration phases, you don't get the whole picture, so you cannot test every scenario. But when you get to production where you really see the system, that's and users can like abuse the system. That's when you get to see some very interesting scenarios. Um, what we do is we actually test we actually receive HTTP logs. We generate the logic of the system, and then we test any API call to see if it fits the logic of the system. This is done in production, which is rather late in the stages, but again, we think that everything should be implemented before that, and then it's like a fail-safe mechanism. Like even after you've tested everything, like something reached production, it should be stopped. Yeah, uh, you can't prevent everything in the lower environments.
Then there's a additional follow-up thing, like is testing enough, or do you recommend any other sort of best practices?
Um, our best practices are write it as write it as elaborate as you can, cover as much scenarios as you can, think as the user should think of it from a business perspective rather than the implementation perspective. And again, write it as thorough as possible and then test it. I mean, if you don't test it, you don't know if it's good. And yeah, generally, after like giving it some careful thought and develop and writing it and then testing it, it should be okay.
Cool. Thanks a lot for sharing. And I've already done a video on Cherry Bomb, so maybe you can give a brief to the viewers, and they can learn more about it with the video that I've done.
Well, Cherry Bomb was meant to give developers and DevOps the tools to uh, actually run those security tests on their API. We have launched the passive testing method, which runs an open API spec audit in your design stages. And we are about to release an active testing module that runs implementation checks and integration tests in your integration and dev environments. Again, totally free, totally developers should use this tool. We believe that developers should use this tool and implement it into their CI pipelines because its APIs are a danger now and they should prevent it as early as possible.
Hmm. If you learn more about it, you can check out my walkthrough on it and the documentation, obviously. You can find the links in the description below. So one more question I have is, since we're talking about, like you mentioned, organizations and stuff, right? So, there are folks who are breaking down their monolithic applications into like microservices, and they're following this cloud native approach sort of a thing. So obviously there's a huge, use of APIs, and obviously that leads to more room for vulnerability, right? So, and when we talk about like, for example, API gateways, and we talk about service mesh and stuff, that adds like another layer for you to manage your APIs and services and stuff. So when it comes to like microservices or whatever, in terms of API management, do you have any experiences to share, or any pointers or any good best practices?
We run a microservices environment ourselves. So again, I'll share from our experience because I mean, your experience is the best experience. Um, we use the AWS API, REST API gateway, and we use the OAuth. I mean, again, with microservices, it's way better to document them and to design them with documentation at hand. Like, it's way better to documentize them. I mean, create a document that actually describes your API and then generate documentations from them, generate the gateway from them. This is why we fell in love with the open API spec and with the design and with the everything regarding API design and API security. APIs are turning into, I mean, most of the internet runs now on APIs. So APIs are the new thing in the new kid in town that everyone should protect. Um, we try to help you get there. I mean, I don't know if this needs to be elaborated. There is no single developer that we've talked to that goes to sleep at that develops APIs that goes to sleep at night without thinking that his APIs will be abused. I mean, zero.
Hmm.
So yeah,
So when we
this
talk about so when we talk about this, the worry thing, and obviously we talk about like security and fine, but before that it comes to identifying the vulnerabilities, right? So as as it grows and as your API scale and the all these things happen. So in the entire like life cycle, obviously it's easier said than done. So when it comes to identifying vulnerabilities, just one last question is, um, including like the maintenance of it, according to your experience again, do you have anything to share?
Well, adding an API endpoint to your already existing microservices infrastructure, it's pretty hard because you have to think about um, where does this point the endpoint fits. I mean, which endpoint will be used in conjunction with this endpoint, and whether or not you're entering it into an already existing API process. Like you call an endpoint, you get a response, you use the response to call another endpoint, like contracts like this. And yeah, it's pretty hard, and it's pretty hard to follow it. To follow it, that's why your API should be um, documented extremely well. That's why you should be prepared. Like there is, I mean, I cannot stress this enough. When you add a new API endpoint, it's the most vulnerable time of your API because you did not think of everything. You did not. This is like the shift changes happening at dawn. Like this is the most vulnerable time of your API when you add a new endpoint because you don't know everything and you should test it like nothing you ever tested. I mean, again, most vulnerable time, no questions asked, and um, it's a
Cool. Yeah, it's tricky. All right. Cool. Thanks for sharing, Guy. Lee had a great time talking to you. But some of the standard stuff as well, like using like tokens, encrypting your data, and things like that. Um,
yeah.
a bunch of things
Use
you have to keep in mind. Yeah.
Yeah, use JOTs, we recommend use JOTs, use clear authentication flow. I mean, flow, use like, again, document which user should reach which endpoint with which data, stuff like that. Encrypt your data, of course, HTTPS, stuff like that. Never use basic authentication or never use like a basic authorization scheme. Never use bearers. Don't use basic. Use bearers, jots, stuff like that. No basic. We've seen five too many companies that use basic authorization scheme, and yeah, don't. Um, yeah, those are the keep your. Here's another good tip. Put alarms on your API gateway. It allows you to. Most of the API gateways in the market allow you to set alarms for multiple uses and stuff like that, for common scenarios of your API. So set those alarms, get them to your phone, to your email, like know what's happening in your API real time so you can prevent it yourself.
Amazing. Well, thanks a lot for sharing, Guy. Lots of best practices and things we discussed. But if you want to learn more about it, you can check out the links in the description below. Really appreciate you giving the time, and thanks a lot for joining. And thanks everyone else for watching as well. We'll see you in the next one. Have a great day. Bye.
Thank you, Kundam.